Welcome back to Lesson 5 quiz, and I was on question number 4, and I was getting a little long-winded, like typical of what I do, so I'm going to kind of erase a little bit of this. But we had decided that, actually I'm going to erase all of it. Alright, we had gotten to number 1 was definite yes. And then we're on number 2, and it says, in pre-tensioned members, the tendons are grouted after being stressed. And I would say no. This is post-tension. Typically of post-tensioned members, that's what they do. And you don't have to grout it. But what post-tension is let's get on like a box section girder. I've seen some box girder bridges that look like this, and they have these holes. And these are kind of tubes, I would say. And what they do is they have this section, which this is the entire section right here. And they'll go and they'll put this up, and then they'll put another section on right here, and you can actually stick a line in there, and then you can post tension it, and that tension will keep these two together. It's kind of like, I guess this is more like a cantilever section, so what they can do. But post tension is they have these tubes. These are open tubes, and they'll put that in there, and then they'll put these sections together, and then they will go through and they will tension this rod. They will get a little jack on there, and they'll go doo, 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 and they'll, once again with the sound effects, they will tension this rod, and then they'll put something, and then they'll tie it, kind of tie it off, I would say. But they'll put it and they'll clamp it so it sandwiches all of these members together. And one interesting, I've always thought, use for this is what they'll do is you'll have something right here, and this will be the support. Let's say this is a bridge, and then they put one on, and they'll of course they have counterweight as well, but they'll tension this. They'll put another one on. They'll tension that, so it all just sticks on. They'll post tension it. Then they'll post tension that, of course. And at the other side, they're doing the exact same thing. So you don't need to build the entire section and then throw it out there. You can instead use post tension sections and kind of walk it out there. They'll post tension, they bring it out, and post tension and bring it out. And then once they get to the middle, they can run the rods that are needed, and they'll run the rods all the way once they get all the sections in. So you can see they come in from both sides, and they meet in the middle, kind of like an arch. And that's just one of the uses of this post tension. But the post tension is you do it after you have the hardened concrete, or the cured concrete, to use more technical jargon. But after they put these strands, and they post tension those strands, they can actually fill this with grout, which is typically what they'll do. And it's a better, well, what I like to say, better way of going about it. You can leave it empty. But number 2, it says in pre-tension members, and that's not how pre-tension is done, because remember, in pre-tension you have a form, you have a block at the end, and you thread all these threads through, and then you dump the concrete in, let it harden, and then you cut the strands, and it pops up. Alright, so number 2 is a definite no. Let's go to number 3. In post-tensioned members, the losses of pre-stress are usually less than in pre-tensioned members, and that sounds good. I would agree with that. And I can go back and read what they say in the study guide. I've been horribly long-winded on this problem number 4, so I'm going to just press through. Okay, so I would agree with number 3, yes. Number 4 is pre-stressed members are economical because they have lower material and labor costs than non-pre-stressed members. And I would say that is true as well. So we are true for what? Number 1, number 3, number 4, and then the last one, number 5, says pre-stressed member, or actually let's go back to number 4, I didn't really explain that. Pre-stressed members are economical because they have lower material costs. That's true. And labor costs than non-pre-stressed members. I would agree with that, both because lower material because you're using I know that sounds stupid, but less material. You can make smaller cross sections because you are previously pre-stressing the concrete. You're using, I guess you're using the concrete more efficiently, if that makes any sense. But you can use smaller sections, so that's lower material and labor costs. I would agree with that as well because these are precast, which means they're cast ahead of time, where they just put them in the pins and then they do it that way, and they come out and you just set them in. So I'm assuming you don't have all the putting up the forms and having a lot of a big crew out there. So I would agree with that. So I'm gonna go say yes to number 4. That was my little explanation. Number 5, it says pre-stressing is not economical for long repetitive members. And it says not economical. I do not agree with that. I believe it is economical. And let's see, 1, 3, and 4. 1, 3, and 4, and that's not one of my answers. Shoot. Let's see what they got. Go to the back, and they say D, 1 and 3. So they're saying 4 is incorrect. Pre-stressed members are economical because they have lower material and labor costs than non-pre-stressed members. I straight up disagree. Apparently they just think 1 and 3 are right. I think 4 is right as well. But you can take a look at that and read through it again and see what you have to say. Maybe I'm not seeing something. But once again, I never like these worded questions because I think sometimes they're left open too much interpretation. All right, so they say it's D. I say it's D plus 4. But once again, read through it again and see what you think. I think they are economical. All right. Number 5, a rectangular concrete beam with B equals 12. B equals 12 inches and D equals 24 inches is to support a floor load, assuming that F prime C equals 3,000 and Fy equals 60,000. This is the strength of the reinforcing strength of concrete. What is the minimum flexural reinforcement that may be used? So when it says minimum reinforcement, we know that we're looking for minimum ratio, and that equals, you can look in your ACI book. Hopefully you have one. If not, you can go turn back. I would recommend that you look in your ACI book so that you can see where it comes from. But I would just go back to page, what page was that had it in the study guide? It was page 90, and page 90 has minimum ratio equals 200 over Fy, but not less than 3 F prime C square root of that Fy. All right, so let's go ahead and figure out what these are. 200 over Fy, 60 KSI equals, I'm going to use 60 PSI, and once again this is 0.0033, and I changed this to PSI right there. Alright, and then once again we have, what do we have, 3,000, so it's going to be the same as we did earlier, but we'll go ahead and write it in there. It's going to be, what was that? 3, it's going to be less than that, but anyway, so let's go ahead and do it. 4,000 PSI over 60,000 psi. 3 times 4,000 square root of that divided by 60,000 is 0.00316. Alright, so that's less. It says but not less than this. And it's not, it's greater. So this is what controls. And then when you go look down, what is the minimum flexural reinforcement that may be used? So remember, this is our ratio. Control ratio. Okay, so you have our ratio. And you could say that the area of steel men equals that times, well, actually I don't need to put that in parentheses, but BD. So 0.0033, B is 12, 24 is, no it's not 24, let's try that again, 24, and that equals 0.95. That should be inches squared. Then we want to go look to see, that's our minimum steel area. So that's AS min. Then we want to go back to page 87 where you see the ASTM standard reinforcing bars. And you want to take a look and see what will get you that. So you could say, well, we could have one number 9 bar, which typically you don't want to do just one bar. And since its width is 12, I would say at least 2 bars. You'd be pushing 3, might be okay, but 2 would probably be something you want to use. I would use 2 bars. So let's go see. Divide that by 2.95. And you get 0.475. So that's bigger than 2 6s, so it'd be 2 7s. 2 number 7s. See if that's our answer. Yeah, D. 2 number 7 bars. So I would say D. Now this may be a little bit confusing. This AS equals ratio times BD. I would look at it. I would just do this. The ratio min equals the area of concrete. Oops, I mean the area of steel over the area of concrete. And then the area of concrete equals BD. So you could say area steel over BD. And then you just do your algebra and you say that area steel wants to stay there, so you have to multiply by BD. I hope that makes sense. So you want to times BD on this side times BD on this side. This cancels out. This cancels out. We're not looking at this anymore. So you just get BD times, I have to figure out what that is. Let me think. It is rho. I want to say rho, but my Greek is less than pristine. Alright, so let's say rho min BD. I hope that makes sense. I'm sure it does. Alright, where are we at? We have a minute left, so I'm going to go ahead and stop the video because it looks like number 6 is an answer, a word problem, which always takes a little bit longer. So I will see you on part 3 of lesson 5 quiz.